All right, Paul. So this exploding egg idea really just doesn't make sense. It doesn't look like the universe we live in. So perhaps there's an alternative.
And luckily, a fairly smart guy you may have heard of by the name of Albert Einstein came up with one. And his idea is there is an alternative. The Big Bang was not an explosion in space, where there was space and something that exploded. It was actually an explosion of space. Einstein's idea is that space itself can do stuff. It's not just the passive stage on which matter goes around and does its stuff things. It actually can, for example, expand, shrink, get curved, do all sorts of stuff. This is the theory of general relativity.
So space itself may be expanding rather than you and me, for example, moving apart.
So that's right. So if you're a distant galaxy and I'm another distant galaxy, it's not as if we're moving away from each other. All that's happening is more space is appearing between us. It's welling up. It's a very slow rate. It's about 1 part in 10 to the 18 per second. So it's not why it's hard to get to work every day. That's an altogether different explanation. But it's carrying us apart. And the more space there is between us, if we're very distant galaxies, there's more space between us, all of which is growing, so we'll appear to be moving away faster. If we're very close together, there's only relatively little space between us, so there's not so much space to expand, so we're only moving away from each other slowly.
So you might think that if space itself is getting bigger and bigger, that everything in the universe, including yourself, telescopes, will be getting bigger and bigger as well. And of course, since we judge everything in a relative sense, our rulers might be getting bigger. So how would we possibly observe this at all?
I mean, if everything really was getting bigger or smaller, I mean, it could be doing it 100 times a second. The universe could be double, shrink, and we wouldn't even notice because we'd be doubling and shrinking at the same time. Luckily, Einstein's theory is a bit different from that. What Einstein said is, sure, there is more space swelling up, but it doesn't affect things that are bound together. So, for example, my head and my feet are attached because there's a whole chain of atoms all the way up and down, each of which is chemically bound to each other. So they're not being pulled apart by the expansion of space. Likewise, Brian and I are both standing here, and our feet are on the ground, and the ground is chemically bound. So while more space might well up between us, it wouldn't carry us apart. We're attached. Similarly, the Earth is not going to get pulled away from the Sun because we're gravitationally bound to it. The Sun's not going to get pulled away from the middle of the Milky Way galaxy because it's gravitationally bound. So things nearby are not expanding because of this. It's only when things are so far apart that there is no binding force between them.
At least not enough binding force, right?
Yes, so like distant galaxies, where the gravity between them is not enough to bind them together, only then are they being carried apart. Now I've got a simulation of this, of course.
So, Paul, this simulation is a simulation of expanding space.
Yes, so we've got an infinite universe that's expanding, so you can see everything's being carried away from everything else.
But it's kind of interesting. It's changing, but it always looks the same. How did you do that?
Well, as you can see, there are new galaxies appearing all the time in this. If you just had a fixed number of galaxies and you made them expand, the universe would get boring pretty soon because everything would just get so spread out you wouldn't see anything. So in this one I've cheated and I violated perhaps the most fundamental law of physics, the law of conservation of stuff. Technically, conservation of mass energy. What I've done is I've said more stuff appears.
So you're
Go back
actually
and run it
adding
again.
stuff.
As you can see, lots of things popping into existence here.
So
I have
these
to.
things that suddenly pop up are new things. So you're just manufacturing mass from the ether, from space itself.
Yeah, yes, that's right.
Well, that sounds a little hokey.
Well, this is what you need if you want the universe to go on forever and look the same all the time. And that's what we've said we wanted. We want to be not special in space. We also want to be not special in time. If you want a universe that's lasting forever and is expanding, this is what you need.
But what happens if I don't want to make stuff all the time? Let's say I don't want to do that. Is there an alternative?
Well, I suppose we could do the same thing, have an expanding universe without creating more stuff, and it would look like this. I started off very dense.
There's lots of stuff here, and so it goes everywhere. There's no edge. Goes on forever. Infinite?
Yes, the idea is the universe was infinite at the beginning, and while every dimension gets bigger, multiply infinity by anything you like, and it's still infinity. So it's getting bigger and bigger and bigger, but it was infinite at the beginning, it's infinite at the end, and everything is moving away from everything else. And just as before, the further apart two things are, the more space there is between them to expand, and so the faster they seem to move apart, giving us the Hubble Law.
So this sort of looks like the universe we live in, but it's different over time.
Yes, so a universe like this can certainly explain the Hubble Law and the expansion, but it's a universe that changes with time. It's not like the first idea where I created more stuff, what's called the steady state theory. This one is a universe that changes and evolves and goes from an incredibly dense state to a really rather boring and empty space.
Okay, so that at least sounds like we can tell whether or not stuff is being created all the time, or whether or not it is going to be like this. And presumably, Paul, there's some ways to test this, and you're going to tell about that next.
Yes, so in the next video I'll talk about the way we test it, and the basic idea is, does the universe change? If the universe is unchanging, that sounds like the steady state model where more matter is appearing. If the universe is changing quite a lot, that sounds more like not getting rid of the law of conservation of stuff. Things are packed close together in the past. So that is indeed the subject of the next video.